Okay, so I've started recording. So we will start with a little recap of what we did last time. Okay, and so we started with the generation, what kind of generation happens, where it happens, how it happens. Okay, we didn't go into the detail, but general overall, the clean technology as well as the usual conventional technologies that is being used for creation of electricity. Okay, then we studied about the different energy resource maps, sorry, places available in India. And the map was there to show you that where is the coal available. Do you see the map? Okay. Then we studied the difference between the water supply and electricity, just to give you the brief that it's all about, I mean, basically give you an idea of how the sources is different in electricity and water supply, just so that you can understand how it is. Electricity is a little difficult topic to understand since we don't deal with it. And as an architect, we really don't even need to think about giving spaces because the conduits are pretty small, and so overall, electricity can be taken care by the consultant completely. We generally don't come into the picture as long as my layout is done. So from a purely architecture point of view, if I see, my job would be to see how I do my layout. So if you are given a house to do and you have to prepare an electrical layout, what all you need to do, we will be doing that. But I'm just telling you that you need to prepare a plan where you need to give me the position of fans, lights, plug points, and how do you show it, indicate it. You will have to actually create a plan. Okay. So as far as electricity is concerned, that is my limit. I'm fully interested in knowing how my room is going to be planned, and how my points are going to come. How do I calculate the points? What would be the size of the switchboard? What modules it will be? Today we get modular switches, so not like previous one. If you see that huge box used to come there, and with the tick tock T type of switches were there. Today we have modular switches, so you can actually plan your switchboard in a minimum sizes. So all these possibilities is I am interested in. Where the conduits are going, how they are fitting, where they are taken up, really I don't have to bother because they can be hidden very well. And unlike water supply and unlike drainage, where I have to think about leakages, where I have to think about how do I take my pipes, I don't have to bother. So that's one good thing about electricity. Okay. Then we studied how it is carried from source to the city. Okay, so all these points we differentiated it between the water supply and the electricity. So the water is carried in pipes. Yahan pe it is carried via underground or overhead cables. Okay, and they are armored cables. Armored in the sense they are highly protected, insulated. So when I say protected, there are metal sheath around which helps the conduits to be protected. Because when I'm taking it underground, God knows what kind of heavy vehicles and what kind of digging can happen, where it can happen. There is no control over, and we have experienced that digging in Mumbai, right? Anything can start anywhere without anybody's notice, and that can be essentially detrimental for services which is lying underground. So to protect that, we have armored cables. Okay, the movement is either by the, so how do I move the water from one place to the other? Obviously by pumps. We don't have pumps in electricity. What we apply here is potential difference. Okay, and for that we have machines which will do that. Okay, so you have potential difference applied that will push the electricity from the high voltage to the low voltage. Okay, and then you have larger sizes of the pipes. Yahan pe you can have larger conduits. But did we say we have larger conduits? No, because the moment I say I have a larger conduit, that means there will be more free ions in it, and those free ions are creating a huge resistance. And when in a wire, when there is a huge resistance, immediately the electricity is lost and it gets converted into heat. And that means my entire wire can have a chance to burn out if if the heat produced is of a higher kind. And so I have to take care of that. And so the cables would be thinner, but the voltages are very high. And we learned that formula whereby you saw that how the thinner wire can help this thing, right? Then the next one was all the questions that we asked, where we said what is electricity, how do the electrons move, blah blah blah. So okay, so I will not go into all that, but just have a quick look. Okay, so I am more interested in showing you that formula once again, so that you can know that how the wires, because that is very important. That's a usual question that is asked. Okay, V is equal to, one second, huh? Let me go there. Yeah, V is equal to, sorry, not equal to, directionally proportional to current. So higher the voltage, higher the current. And that's what my entire idea of taking the electricity one point to the other. Okay. So where did we finish last time? We finished all this, right? All the formulas and this thing we finished. Hmm? Okay, so we were now at the distribution level of the, at how we were distributing at the building level, right? And we were talking about bus bar, right? So I remember now. So let's go there. So we talked about transformer station, we talked about substation. Do I need to go into that detail? If yes, please tell me so that I'll go back into the detail. Otherwise, I'll start from the distribution. Please, someone respond. Okay, so I assume you understand what is a transformer, okay? It's basically a machine which takes the voltages down, because I cannot supply electricity at a high voltage. It's extremely dangerous. Even 440 volts can take a life. So I need to supply, so imagine 11 kV, 11,000 volts is a terrible thing, right? It can blow up cities. So I cannot supply at that level. And so I need to bring it down. So you have step down transformer. And if you wish to take it up, you have step up transformer. And similarly, the substations are the places where it is distributed. It's a station from where it is distributed to sub areas. So that's my substation. Hmm? Now, this is where my main interest is, and that is how the electricity is distributed within a building. Now, and we discussed the scenario. So in some buildings, you have mixed use, where you have niche some shops and above you have some homes, houses, or you have a mixed use where you have partly industrial, partly commercial, and then you have your normal homes. Okay, so you will have these multiple mixed use kind of a thing in such a scenario. Remember guys, the tariff rates for electricity for various sections of uses is different. So for house it is the minimum. Okay, residential usage electricity points charges are minimal. Then comes the commercial, and the highest is the industrial, because industrial machines really consume too much of electricity, and that's why they are charged also. And plus it's a commercial thing, and they are making money out of the services that is being provided. Houses are not making money. It's a provision that a state is supposed to provide to them as a basic amenity. Okay, and so that is not considered as a part of a commercial loop, while these are the places or the land uses where they are making money out of the services applied or given to them, and so they are charged heavily. Similarly for the water also, guys. So even for the water, a commercial outlet is far more charged, 10 times more than a residential unit. Okay, so if you are paying $8 for 10,000 liters, the commercial will pay 80, and I don't know what is the rate for industrial. Okay, commercial will pay 80 and industrial probably even higher. So that's how the entire layout is there. So what happens to the electricity at the building level? So obviously there will be one conduit which is going underground coming from the substation. Substation, say it goes to the feeder pillar. Feeder pillar are nothing but the boxes that you see out on the roads. They are the red color pillar boxes with a cross and bones and a skull marked on it, which is telling you that this is electricity and not the telephonic one. Okay, so from those feeder pillars, it is supplied to some entire, probably a neighborhood of 20, 30 buildings. Okay, so basically it's a layout of conduits under the road, and from which you will take probably one wire inside your building. Now that wire, guys, you have to understand. Okay, imagine and we said we are going to take 30 people, right? So we started with that last time. So imagine you have 30 flats in your building. Okay, and in that 30 flats, you have some 7 to 10 shops, chalo, for a good number. So probably you have 10 shops and 30 flats, And plus you have society ka pumps, you have lifts, okay. You might have some other things around. You have the staircase lighting, the lighting for the compound, lighting for the terrace, and all the other extra stuff that is there under society and not under any personal use. So you will have so many things to cater to. So when you are talking about that one single wire coming in, guys, keep in mind that that wire has a capacity to light up the entire building. Hmm? So don't take it lightly. So when this wire comes in, it comes in a very protected mode. Okay, it has to be highly insulated. It has to be protected, and then it enters into a room called electric room. We call it as a meter room, electric room. So there are multiple names, jargon, which is used by different architects in different manner. So whatever name you wish to apply, you can use that. Both the names are correct. So if I say a meter room, so it enters there. And then as we had a stopcock by the BMC in water supply, where the BMC can come and shut the watercock, and you guys are bereft of the water because you have not paid bill. Similarly, electricity is also having a stopcock, but iska naam hai cutout. Okay, so I will have a cutout switch. It's a fuse kind of a thing. So in case if the society fails to pay electric bills, okay, it is the whole thing is taken out. Now the question here is, guys, society has not paid the bill. यानी कि तुम्हारे pumps, your compound lighting, your terrace lighting, your lifts, anything extra. But you have paid the bill. You are staying in that flat, 30 of you, all of you are paying your bills regularly. The commercial guys are paying their bills regularly. Will this cutout switch affect all of you? No. It will only affect that part of the electricity to which the meter is connected. So that means this cutout, okay, is divided into various kind of different cutouts. I mean, it's not just one single cutout. So when I say a cutout for KRVI, there will be one cutout. But when I say for our building, the case that I have put in forward, that is 30 flats, 10 and one society, there will be 41 cutouts. Great. So that is how it is divided, because I cannot penalize someone who is paying the bill, but society has not paid the bill because the chairman is lazy, the treasurer is lazy, or whoever it is. Okay, they have not bothered to take their duties up. That doesn't mean that the 30 of and the 40, 10 of the commercial are penalized. So what happens is when the line comes in, okay, there is a cutout switch, okay, which is for institutional building. Coming to our building, it will not be a cutout. It will directly go to bus bar. Please understand this, okay? You want to write it down, please write it down, okay? Actually, you should be writing down the notes and submitting at the end, because that's the only way I know you guys are there. So what happens is, in a mixed use kind of a thing, there will not be a single cutout, okay? There will be multiple cutouts. But before it gets multiplied, you have to question, एक वायर से अनेक वायर कैसे होता है? Okay, from one water pipe, I am getting supplied because I am collecting it in a tank, and then from that tank it is going up, and then via that thing I am getting a one single line and then individual line. So it's a gravity fed system for water supply. Electricity में ऐसा कुछ है नहीं. So how do you then multiply from that one single wire that comes into your society into this 41 types? One goes to the society, one goes to the 30 flats, and 10 goes to the commercial. तो आपको इतना division करना है. How do you do this division? That is why the bus bar comes into the picture. So if you read the thing, the next step in the line is the bus bar. Okay, so the bus bar is a long strip of copper. Entire bar is charged. So it's not just one, huh, guys. There are three, because you are whenever it's a small bungalow, I can go for a single phase. But when I'm talking about a building with 30 flats, each one of you having a geyser, each one of you having an AC, probably two ACs if you have two bedrooms, okay, or three even if it is for the living room. That means there is a huge consumption of electricity. I cannot even think of single phase supply. It has to be three-phase supply. That means there are three live wires and one neutral, which is the connecting back this thing. So I need three strips of copper, and I'll show you the picture. Don't worry. So you will have three thick copper strip, okay, and let me show you the picture, okay, which are then taken to the individual meter, okay, and then to the fuse. From the fuse, it is taken to individual flats and to the main distribution board, and from then on to the various DBs. Did you understand this? Or I'll show you the picture, then I'll go back to the slide. So this, do you see this? The top picture with a blue background, okay, or any of them. See, there are three tubes everywhere, four basically. One is for the, if you see the thick ones, they are the live wires, okay, and thin one is the neutral wire, okay. So this is how,
Neither we
this
don't
is
see
how,
the picture.
can't,
Yeah,
sorry. Okay, can you see the picture?
yeah,
Okay. So now do you see? So there are three thick copper tubes. Okay. Sorry, not tubes, strips, and one is the thinner one. Now the thinner one is for the neutral. Neutral is not. It is just a loop connecting back. Okay. So the live wire is your the other the thicker one. So if you see the niche wala picture or even any of them, you will see at the end there are these tiny bolts that is there. So what happens is when the wire comes in, you open that conduit, okay, and then you chip off the little bit of insulation with the help of course you are wearing gloves and everything, all protection gear, because that wire cannot be shut off. But even in the feeder pillar box there are switches which allows you to do that. So yes, there are these, I do not know at the what happens at the city level, how do they perform, because you really require a very highly accomplished electrician to, ये आपका कोई normal electrician काम नहीं कर सकता है. You require BMC affiliated electricians to come and get the main connection inside the building. Similarly for the water supply, no simple plumber can work. That plumber has to be affiliated with BMC, who will come and do all the connection. Then you can call the normal plumber for the internal work and all that. That is fine, but these main connections are done by the BMC or whoever the services is being supplied. So so what happens is to the strip, do you see on the top wala, there are these holes there, okay? But that means that within that, behind the strip, there is this nut and bolt. So you loosen the nut, you fix the copper wire, and then you tighten the nut. So now what you are doing is you are basically making the entire strip very, very highly charged. Okay. Whatever the volume or voltage is, that is. Now, if you see the niche wala picture, you see those dot, and they are nothing but the different volts. So I can take n number of lines from that. Okay. So I can distribute my entire 41 connections on these three strips. Okay. So if I say that commercial and the heavier, the society wala thing, which is requiring higher, probably I will give one entire strip to that. And the other two, 15 houses, I can put on this and I can finish my entire this thing. And guys, you cannot say that these copper could be anything. So according to the load, the thickness is measured. So there are a lot of these kind of technical thing which as an architect I really don't need to go into it, because they have to look into the kind of load that is coming. Will it get heated up? If it gets heated up, will there be a problem? Will it be able to take the load? Will it not melt? All that kind of thing, because copper is highly malleable. So all that things are taken care of. You and me are not engineers and we really don't need to go into it, but you need to know that this kind of stuff comes into your meter room and how the distribution happens. So pipe aya, okay, it gets distributed and now it goes to the cutout for those 41. So that in case room number or a flat number 412 has not paid, okay, the electricity, the cutout of that is taken out. And so everything else is working. 412 is not working because electricity has been cut out by the supplier. So that is how the distribution is. So when we ask you these questions, you have to be very, very aware of the distribution part. Okay, and generally the best way to show the distribution, I don't need to know all this. These diagrams are not important. What diagram is important is for you to understand how the things are. So you can, if you write like this, that first is the cutout. In an institutional, if I ask you, from the cutout, it will be the bus bar. But for a mixed use, it will be first the bus bar and then the cutout. Please remember all these things, okay? Next, you want me to go back to the first slide? Okay, so going back to the first slide, uh, please read it out. The next step is the bus bar. It's a long strip of copper. The entire bar is charged, and from there, number of connections can be derived. Just as at a terrace level, looping of water lines is done, so that infinite downtakes is possible, which are then taken to individual meter and then to fuse. Okay, and from the fuse, it is taken to individual flats. Now, uh, this is what I am saying is uh, so there is a fuse also for the line. Okay, what is the function of the fuse, by the way, guys? Anyone have an idea? Somebody said nostalgic last time. That means you know what you did some time back. What is the idea of fuse? Why do I need a cutout pehle and then a fuse baad mein? Basically, both are fuse, but naam alag dete hain because cutout is like you have BMC stopcock, which is a separate name given to that because it is meant for BMC. Similarly, cutout is meant for the supplier. When I say the fuse means that uh, fuse. The function of the fuse is that it protects the line ahead. So, in case if there is a fluctuation of current within, if there is more current drawn, and it protects my entire circuit. So that is the function of the fuse, and we'll do the circuit protection later on, which are then taken to individual meters and then to the fuse, and then finally to the distribution box. What is all that? We will study. So then we saw this, and then the next is, so these are the then how the distribution happens. Okay. So in the distribution, if you see the first one, okay, that is actual picture of how the meter looks. Okay. So P in is the incoming phase. Okay. P is the phase and in is the incoming. Okay. Or live wire. P out is the phase which is leaving out. Okay. N in is the incoming neutral. Okay. And outgoing neutral. ठीक है, तो ये आपको ध्यान में रखना है to show in a diagram of how. So if you see the next one, it is a diagrammatic form of trying to tell you. So the first one is the picture wala jo hai, the black one on the extreme left is your normal picture of how the meter looks. Okay. Similarly, the niche wala. But the top one is a kind of a diagrammatic way of showing how the meter looks, and that's a three-phase line. So you see three colors and you see black neutral. So for every phase, you don't have a separate neutral. Neutral is one only. Okay. All of these are coming. So the neutral ka job hai is the connecting loop back. So it's not really carrying the current. If I disconnect, it's okay. But live is carrying the current throughout. Okay. Whether it goes into the appliance, whether it is coming out of the appliance, it is carrying current. It's a live wire. And the color we denote with the live wire is red, blue, and yellow. So these are the common color coding for live wire: red, blue, yellow. Black is always for neutral, and green is always for earthing. Okay. So this is how my three-phase meter is. The top one is the single-phase meter. So if this is my three-phase, you will have all three wires coming in and coming out. You will have black wire coming in and out. So that is how the connection is done. Next, again, similar picture trying to tell you that this is how the phasing is done. Now, do you see the thing like a spring on the top? Those are my fuse. Okay. So this is the niche. You see all those incoming lines and all that, right? And then they're coming out. Okay. So these are the fuses which is helping me to keep my circuits safe. Okay. And what are those? We will study again. This is just the diagrammatic way of telling you that this is how it works. Again, another simple diagram. I have taken it from. You can go on this site. It's really amazing. You will get all your. If anybody is interested in knowing more about electricity, please go here. Intricately, everything is very detailed out. Okay, all kinds of questions are answered there, and they're too intricate, so I didn't take everything. What I felt was necessary, I took it. So when I say, suppose you are having a bungalow and it's a big one, and you wish to now distribute. So this is how it is done. So if you have a single unit, single person supply, okay, like say KRVI, forget bungalow, we take KRVI. So if I have KRVI and if I have to do this, so then the loading is distributed in such a way that each one of the wire is equally distributed so that not one single wire takes too much of a load. तो सबको इक्वली डिस्ट्रीब्यूशन होता है. सो वन गोज टू द मोटर. सो मोटर को देखो तीनों लाइन जा रही है बिकॉज इट टेक्स मोर वाटर इलेक्ट्रिक सप्लाई. वी नो दैट, राइट? When a pump starts, pump takes huge amount of electricity. So if you see here, the pump, your lift, your geyser will have this kind of three-way supply. Geyser, I mean the boilers of the large quality. So if you have that for your for your building, I'm talking about that. Sorry. Yeah. So you will have three-phase supply. Then you have individual supply. So maybe the blue one is supplying your TV or computer. The yellow one is just supplying all the lights. All the fans are being supplied by the red. Huh? So ऐसे आपका distribution होता है. And again, this is not your purview. This is not an architect's purview of how the distribution and the loading happens. This is completely done by the electrical consultants. For this you do require an electrician with the knowledge. So if it is a small unit, say you are doing a small interior, and if it's a small interior where not even a single AC is used, शायद आप कर सकते हो with a nominal kind of electrical guy. But if it is a large place, you do require an electrical contractor who will know his stuff and who can guide you, okay? Because we learn a lot from them even now. Coming to the next, this is how my meter room looks, okay? This is, by the way, very clean, okay? ऐसा नहीं होता है. Because if you go to a multiple, this is obviously for a single institutional kind of a thing. You see only 1 or 2 meters, one probably for the society and one for the building. And that's how it works. So this is a very clean kind of a thing. But in reality, if you really want to see, I would suggest once this lecture is over, go to your secretary or treasurer or whoever is controlling the building, take the chabi of the meter room and go and see your meter rooms. Okay, it's a scary scenario most of the time because these are the rooms which people do not pay attention, and what happens is they are put away, or I would use a word called tucked away in a corner where probably no good ventilation is there, probably no light is there, and these are dangerous issues, and one need to really address these issues when you are planning. Okay, so as a planner, as an architect, whenever you planning it, okay, see, I'll give you an analogy. Okay, my son doesn't like a lot of stuff to eat. तो वो क्या करता है ना, पहले जो चीज नहीं अच्छा लगता है, he will eat that first, and all his favorite food he will keep last. I also do the same thing. What I don't like to do, I finish it up first faster. And then I sit and meditate over the things, or over the things that I like to think about. Okay. So similarly, when we plan, all the services that is needed and which I need to have it, whether I like it or not. Okay. Because without it, my building is pointless. So if that is the thing, ये सब आपको पहले ही design करके or keep it as in a background. Yes, I will need a meter room. Yes, even if it's a small house that you designed in second year, you will need a panel, at least, if not a meter room. No house will have a meter room, but at least a panel and a safe place where you can keep it exposed because the guy is coming from outside. In case you are not there, he can see the meter and go out. So meter is always placed out in a protected place. So you need to design this and keep it aside. Remember this, if you really want to come up with good designs and don't want to mess with your services and mess with your design later on, this is the ideal way of designing it. And do not forget that even if you go to the fourth year and you are doing things at an institution at an urban level, because that's what you will be doing when you go there. So when you are designing at an urban level is also constituting people. People need water, people need electricity, they need AC, they need ventilation. So all these things are imperative anytime. You need to take care of this. Okay. So what is then, let's go and see some of the other terms that is, okay. So how do we get electricity where we want it? So it's basically electricity is somewhat selective about what it can move through. We know that there are conductors and there are insulators, okay, or we say bad conductor and a good conductor. So it likes to move through copper wires, aluminium, gold, and silver. So basically metals, but it also likes to move through tap water, rainwater, and people. Okay, don't forget that. You need to be very, very careful. The reason of writing this separately was to make you aware of it. That's the reason when we do fire safety and fire fighting in the next semester, this is the point that you need to remember. All your MNP rooms, MEP is mechanical, electrical, plumbing rooms, will not have firefighting facility of water. So you will not have sprinklers there, you will not have wet risers going inside, no way, because that is double trapped. If you don't die by electricity, you will definitely die by short circuit. I mean, sorry, if you don't die by fire, you will definitely die by electricity. So these are the problems that you need to understand. If it is a distilled water, electricity will not affect it. But if it is impurities there, sulfur hai, phosphorus hai, where it is, where these are the good conductors, okay, you are in big problem if anything happens. And that's the reason why meter room has to be protected. Last night we experienced the rain. I don't know what is happening there. Out here, the roads are flooded, okay, my place, it's terrible. Now, if I do not take care, if my meter room was not having protection of plinth and at a high level, probably I would be out of electricity today. Hmm? So basically, it moves through a good conductor, and conductors are all metals. Okay. There are many materials that electricity doesn't like to flow through. For example, air is one thing that electricity can't flow through very easily. That's why vacuum is the best thing if you want to keep it as an insulator. Okay. Other insulators include rubber, glass, ceramics, wood, plastics. Okay. And surprisingly enough, distilled water, as I already said. Okay. These are known as insulators. And that's the reason why we have a plastic or a rubber insulation around the live wire. And then you will see something what you see in our college. Okay, there is this black color ka thing. That is actually a thickened PVC covering, which is working like a conduit, and it's very difficult to bend. Okay, it is bendable. I'm not saying that you can bend it easily, but compared to wire you can like fold it and keep it in your purse or a pocket. The conduits cannot be done that, okay, because they are stiffer, and so they protect the wire within. So you have that conduit, and then you have the wires which is running in. So not the live wires, the insulated wires, okay? And then those are traveled up and down wherever you wish to take it across your building. Then we come to the, then we come to the next slide, and that talks about circuits. So you have three phase and you have a single phase. I'm not really going into detail here, okay? But understand, single phase is for a simple kind of a dwelling. So a house or a flat can have a single phase, okay? But you have multiple kind of flats happening. The whole building will have to go for a three phase, and a single phase will never work there, okay? It will be very burden on the electric wires. Okay? So how does the current enter the site? That is in a single phase or a three phase. As mentioned earlier, larger current requires larger cables, which are expensive and not a very good idea because they use a lot of electricity. Not only they are expensive in terms of loss of electricity. Okay, so I end up paying more bills. So in a three phase, one can get more amount of current in the premise, but balanced in three cables. So what I'm doing is, instead of taking one thick wire, I don't want to lose electricity because I explained I is equal to V. Okay. What I'm doing is I'm distributing it into three cables. It is a three phase, but I'm supplying it into three this thing. AC is alternating current is used in house instead of direct current because it can produce high voltage efficiently, transport it over long distances, and then it is lower it to a safer level, which is not possible in a DC. If you see the diagram of AC and DC, it's an alternating current, right? So alternative current goes to zero, then it rises to the maximum capacity, again comes to zero, goes into minus, goes there as a, so it has troughs and lows, okay, valleys. Not so in a DC. DC is direct current. So what happens in an alternating current is, it gives you seconds to, it throws you away. When it comes to zero, you suddenly get a jolt of being detached from the appliance if you get a shock. Okay, and this is like, fractions of seconds these things are happening. That's the reason alternating current is safe for you. But had it been DC, it stays at one level. एक बार चिपक गए तो चिपक गए, then you are gone. So that's the reason why we don't have DC in the household. So your electrical trains run on DC. So there was a big talk going on. I don't know whether it has happened or not. But at the city level, the talk was that they were planning to convert that too into AC. I am not aware of where the project has gone till now. Okay, so now let's study about a little bit about the circuits. So the circuits are many again, okay? So you know the series circuits, you know the open, parallel, short, okay? Let's go one by one. So when all component parts are connected end to end, yani ki, say in your studio, okay? You are in a second year studio up till now. You have never been to third year till yet, okay? So, so you are in a second year studio. You switch on one light, switch uh, put on one switch, multiple lights will go on. That means light को हम L1 नाम देते हैं. L1, L2, L3, L4 is connected to one switch. So I can say switch 1 is in a series of 4 lights. Did you get this part? Huh? You will see series lights in all these decorative shadi wala light, Ganpati wala light. They are all in series. So one you put on, every light will go on. Nobody goes and sits and put individual lights on, right? We don't have that kind of facility during that short time. So every light is on series circuits. Those series is fine for this kind of events where it's an event happens for 2 to 3 hours and then you take it out and or maybe 14 days, 10 days, 11 days and then आप निकाल लेते हो. Unlike on and on and on like what we have in our studios, series, if it is a corporate office or a place where you know that a lot of monitoring is done, okay, in terms of people or machines, somebody is keeping an eye and taking care of all this, okay, then the series is fine. But in places like our studios, where students bunk the class, or maybe half the class is not there for whatever reason, like aaj jaisa barish hai and some people really stay far, they cannot come. And so half the class is empty, but you are sitting at your designated space. So even if you are sitting alone in that corner, तुम्हारी सारी की सारी lights चालू है. And who ends up paying for this humongous loss of electricity? College. Okay. So for such kind of institutes where monitoring is not done, where this is not possible, you go for parallel switch. Parallel means one switch to one light and it ends. The other switch to when components are connected individually. I am not connecting it in a series. So if there are 20 lights, I will have 20 switches. Yes, it is costly starting May. When I'm installing, yes, I will have to buy those 20 switches. But in the long run, after 15 years, I have recuperated that cost in the first year only. Within that first year, क्या 6 महीने में वो cost recover हो जाता है, right? So is it better to have parallel or series is something an architect decides, okay? Because when we plan, there is an overall umbrella of sustainability also that we are simultaneously thinking while we are thinking about our forms, about the climate we are in, the energy that is there, that is being used, are we using alternative energy? So all these questions are there in the minds of architects. And how do you tackle them each one? And these are some of the ways you can tackle them. Then you have open circuit is simply breaking, is simply a break in a conducting path, okay? And a short circuit is occurs when a two live wires comes in a contact with each other. When the open circuit is broken, you get a short circuit. It's simple. So these are basically the circuits that you will generally come across, okay? And this is how the distribution is shown. 1 second. Yeah. So this is how my, you see the first diagram. You see the meter. The meter is having a single phase. You see a red line coming in and a black line coming in. Similarly, a red line coming out and a black line coming out. Okay. And then it goes to the fuse. Do you see that? Okay. Now this is not the cutout fuse. Okay. Cutout fuse will be before the incoming line. This is outgoing line which will have the fuse to protect the line going from the meter to your area. Okay. तो अभी ये आपका imagine करो, this is traveling, so this fuse will be in the meter, okay, it goes to the bus bar and it gets distributed into this various, and each red line is then taken up via conduit to your place, okay. This was in a single, say, a small building or a small house or a small bungalow. This is possible. In a flat, the second diagram works. So you see that overhead line from which I am taking the line. Obviously, I do not take. Please, this is completely wrong. But this is what happens when you take diagrams from the internet. Okay, do not show like this. The line always comes from the फीडर पिलर because ये line का जो voltage रहेगा ना 11,000 volts रहेगा which I don't want to shock my entire building. So I will be taking, you will need to show me that the line is coming from there and it's coming from a feeder pillar, or instead of that thing you have to show a red dabba. From the feeder pillar you are getting a three-phase line in. That three phase is not three wires, it is one wire which is then distributed into three. So you will show me only one thing. This is for you to understand, that's why they have done like this. लेकिन अगर आप practical life में जाओ and if you see an electrician and he will tell you that there is only one line that comes in. ठीक है, ठीक है. अभी आपका metering हो गया, so all three live wire is coming in and three live wire is coming out. And before it goes to individual thing, it goes to one major fuse. Now this is for institutional building, guys, because it is showing me only one fuse. Okay, had it been 41 as we do for our building that we have taken up as a case study, okay, it will be 41 fuses there with 41 meters there. यहाँ पे single meter है, that means this is for an institution like KRVI. Now imagine this is KRVI circuit, imagine this. ठीक है, up till now you guys are with me. Any questions? Hello, are you understanding all this?
Hello.
Hello.
Can you hear me?
Yes, I can hear you very much.
Yeah, Mia, can you just once again, like in short, show the series in which the current travels, like from the generator, like in one words, like how
Okay,
in
okay,
one phrase
I'll.
how it travels.
Okay, fine, great. What happens is you have the source. Okay. Now you can write this down, all of you, okay, and send me the photos of that. 1 second, guys. कोई उठा ही नहीं है, सब अभी उठे हैं तेरे साथ. So now you just give it to them. And close the door, please. Yeah, where was I? So what happens is you have a generation point. Okay, so you might have a thermal generation, you might have wind, solar, whatever. So from there you travel all the way to Mumbai via overhead. चलो हम overhead लेते हैं. So you travel all the way to overhead. The voltages are high, and the reason I've already explained. So once it comes here, the voltage is at a huge level. Now I need to reduce this voltage. So I take it to the substations, okay, where I have transformers, where it reduces down via down transformers. Okay, so the voltages are taken down and then they are distributed. Similar sort of distribution happens at that level also. Probably, I don't know whether they have bus bar. I've never been to a substation of a larger city level substation. Okay, it would be very interesting to go there and see how it happens. Okay, but I am assuming that similarly the voltages after it is brought down, the wires will be distributed to separate areas. So let's take a neighborhood K West area where our college is situated. So in that you will have, so you will have various substations happening. Okay, you will have a main substation and you will have substation. So main station, say it goes to the substation. So if, and from the substation again the distribution happens and it goes to individual areas. So again in the K West, जैसे अपना जुहू area है, then you have something called as SV road. Now SV road you will have one on the near the Fatak area, near that that society that they have, probably somewhere where there is Irla. So you will have these various neighborhoods, okay, and each neighborhood will have a distinct apna khud ka feeder pillar, and from this feeder pillar the lines will be taken to various buildings. Now how big is this feeder pillar depends on the neighborhood size. Again, do you think that is within our purview? No. So you don't bother about that. Just remember, this is a a component in the sequence. So from the feeder pillar, it is going to the various building. One of the building is suppose KRVI. So when it comes to KRVI, a single line is taken in. There will be a cutout because this is institutional and only one person is paying this. So there will be 1 meter. Okay, so you have a cutout. In case if KRVI do not pay the electric bills, the supplier will come and they will just remove the cutout and go out. And until we pay, it cannot be done. So then what happens is from the cutout, it goes to the bus bar, okay, or it goes to the meter because yahan pe we don't have to do any separate metering. So it just goes to the meter. Meter mein jaake it starts metering, and then I need to distribute the wire. Na? I don't need to distribute it before and then. So ultimately, guys, see what this is happening. It all depends how you distribute your line depends on who is paying electricity bill. I am really not bothered. Why am I not having so much of intricacy in water supply? Because no, there are no individual meters. But suppose if there was an individual meter, then you will have to do all this thing in water supply as well. Okay. Now, smart city concept that is coming up is actually talking about metering of water and doing smart metering. How do you meter? And if suppose tomorrow, if there is a water meter given to your line, do you think we will end up wasting so much of water as we do today? Obviously, no. Because when the money goes from your pocket, you can feel the burn. Okay. Similarly, electricity, so right now we are paying through our teeth, right? The bills are like huge, especially in this pandemic condition where the engineers are not able to come and have a look at our meter reading, and kuch bhi random bills are coming. Okay. A friend of mine got, uska flat is 2-bedroom hall kitchen, 1 AC, and the bill for 3 months was 22,000. So it's unbelievable. But that's I assume because they have not done the reading, and so they very clearly the letters that is coming to us with the electric bills are saying that please bear with us and blah 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 and all that. So they also have issues, and this is a strange situation that we are living in. Coming to the distribution part, so from the cutout it goes to meter, and I'm doing this for institutional. Okay, it goes to the meter. Meter ke baad I require it to go to various places. It goes to go to the auditorium, then it goes to the canteen, it goes to the niche ka office, it goes to the lobby and the staircase area. Then it comes to the first floor where again you have AV, computer, final year, fourth year, Paul's office, staff room, library, okay, and all those things. So now if you just go and close your eyes and imagine this thing. So near the toilet, both the toilets, okay, you have a staff toilet at one end and the other end you have students toilet. At the toilet level, do you see a large panel there? Just close your eyes, or on the staircase you will see a large level of conduits happening there. That is what this board is showing you. It is known as distribution box, where a big chunk of electricity is coming from the meter room, okay, and I need to now distribute it at the floor level. Now imagine the number of lights, the number of fans, the number of AC on the first floor of KRVI. 6 AC to AV mein hai. Another 6 are in the comp lab. Okay, one is in the Paul's office. The 2 are in the office. So we have around 12 to 15 ACs, and plus library. Of course, I forgot library. I don't know how many are there. So you have library. So around 20 ACs, innumerable fans, innumerable lights. You think one switchboard is good enough? It will burst. So I need a distribution. And every line has to be protected because it's a large area. It's an L-shaped building. Okay, it's a large area. I will need to protect my lines, and that's why just close your eyes, and I hope you have seen it sometime. Okay, there are lots of these black switches there. Lots and lots of small chotu black switches there. Those are known as MCBs. We'll do that, okay? But since you said you give this in a sequence, I'm giving you this. So what happens is from the meter, it goes to bus bar, it gets distributed, it goes to the dB of each floor, okay? Now there can be 1 dB. dB is nothing but distribution box. dB is again a choice or design, whether you have 1 dB or you have 2 dB. Now, if you see our building in KRVI, we have 2 dB each floor. तो 1 dB जो आपके टॉयलेट के पास है, it takes care till Paul's office. The one which is at the staff room toilet takes care of the library and the staff room and the office area. So it's 2L, two part of the L. For each part, they have taken 1 dB. So it's up to how you design. Suppose you had a centralized DB, that was also fine. But we don't have that design, so they take two part of the services. So you have 2 toilets, 2 DBs, two staircases, all at the end part. So that is how it has been planned. So that is the end of it. Now from the DB, it then goes to individual switchboards. So from your, say, the toilet, which is near the toilet, okay, from there it comes to the third year, it goes to the second, I'm talking about the second floor, it goes to the first year ka studio, okay, it goes to the tumhara kya hai wo, workshop, okay, and all the lobby ka lights, all that thing will happen, or the AV room. And then from the staff room toilet wala jo area hai, wahan se it will go to your second year studio, master studio, okay, and your the guy who is sitting there, tumhara stationery wala, whatever. So this is how it is distributed. Is that clear? This was for
Hello.
an institution. Yes.
Yeah. So like from the meter room, it goes to the distribution box and then to the switchboard.
Yes. No, darling. How will it go to distribution box? How will I get into
Uh,
separate lines? I need to separate lines. So it will go
yeah.
to the bus bar chamber. From the bus bar, I take multiple lines, okay? And then also, I also design this. So if it is for a single institute, I'm talking about KRVI. If it is for that, what I'll do is I'll take one wire to first floor. Again, there is no point in conducting so many wires, okay? So probably 1 or 2 wires I will take to first floor, where again there is a DB, and DB then does the distribution of this. So if you see a DB is chota mota nahi rehta, it's a big thing. It's a big panel, okay, which is there at a very high level so that nobody tinkers with it, okay? It is probably you will have to take a stool and access that. It is kept at that level. So the DB of that area will then take care of all the switchboards of that area. So from there, can you imagine otherwise? Okay, just imagine. KRVI के लिए imagine करो. Okay, if it has to come from the meter room, do you know where our meter room is? Under the staircase, which I kept telling you about. Okay, this is what it was planned again. So this is under the staircase of the third year wala jo staircase hai. Okay, at that end below there is a meter room. And it is in a pathetic condition. तो अपने सारे janitors अंदर जाके अपने शर्ट टांगते हैं, खाना खाते हैं, और क्या क्या कचरा पड़ा रहता है, which is so dangerous, should not be done. It does not have a very good ventilation point. Okay, it does not have window inside. So because they thought it's a 1 meter, but it's the whole damn institute. Even if it is 1 meter, anything can go wrong. It should have a ventilation facility. Anyway, so imagine from that 1 meter room, you have a bus bar, and from that bus bar, you take one wire, it goes to computer. Computer का एक AC, computer का दूसरा AC, computer का तीसरा AC. Can you imagine the lines that will be traveling? It will be like chaos. And then suppose if something goes wrong, can you imagine that electrician का headache? Because he will have to attach and run, किसी 4 लोगों को लाना पड़ेगा, and they will keep moving the wire to understand, okay, this is the wire that is finally connecting there and there is a problem there. It's a headache. How will I, if it is G+4 building and if I do this kind of wiring, it is terrible. So what I do is I do distribution in parts. So I get bulk electricity at one level, and from there I do the electricity. And remember one golden rule of electricity is every circuit has to be protected. Every circuit. Okay. तो सर्किट प्रोटेक्शन का दूसरा गोल्डन रूल क्या होता है? जितना शॉर्ट सर्किट का लेंथ छोटा है, easier to manage the heat. So I will try to shorten the circuits as much as possible. What I will do is, now understand this, guys. What I will do is, from the KRVI meter room, I am taking the first line up and putting it towards the toilet area, right in front of the 5th year. There is a toilet and बाजू में उसका electric panel है. I will go and put my first bunch of electricity there. Okay. From that load, I am distributing. So part of that distribution happens. Now I will have lots of those black things. Those are my MCBs. These are mini circuit breakers. So one circuit will go to the final layer. One circuit will go inside the server room. Sorry, computer room. One will go to the AV, and one will go to the fourth year studio.
Meenal,
Follow?
yeah, from the distribution boxes, when these circuits are taken out, are they in series
Hmm.
or are they in parallel?
No. They are in parallel. Because as I said, every circuit has to be protected, and I am taking still a large amount of load. Because when I say I'm taking a load out for say entire tumhara say final year. Now final year will have multiple switchboards. They have nearly 20 fans inside. They have nearly 20 lights inside. Okay. Some plug points are there where people come and charge their mobiles. Okay. Or even projector lagane ke liye I need a plug point. So all this thing is there, and I cannot take single line right from the from the meter room below. What I do is I bring the light up, okay, electricity up. I distribute from the distribution box. I from there also the circuits happen. So one MCB is there, and from there the circuit is distributed to. So when one trip hota hai, then you know that okay, this is happening in the final year, and these are the problematic. So if you see our AV room has three or no, one, two, three ACs it has, right? So you will see 3 to 4 and those huge yellow lights on the top. So you will see 4 MCBs are there, 4 to 6 MCBs are there. So anything goes wrong in that circuit, MCB trip hota hai, यानी वो नीचे आ जाता है. And then you know that this is a problem, इसको हाथ नहीं लगाना. You call the electrician, get the circuit checked. Okay, the circuit check हो जाता है. He says okay, things are fine, and then you trip it back up. So this is how the distribution is done. Okay. Coming to the next part of the distribution, ये जो distribution अभी मैंने लिखा, did everyone write down? Yes or no?
Yeah.
Right. Coming to the second part of distribution, when I'm taking individual building, okay, now the distribution will be different. Okay, now please pay attention. Okay, what happens in the individual buildings or individual flats or commercial areas is, first of all, if you have two things, you will have two metering system. One is for the commercial, one is for the residential. Now guys, electricity को कुछ मालूम नहीं है कि ये commercial है कि residential है. Electricity is nothing but flow of electrons, whether वो तुम्हारे लिए है या मेरे लिए. It doesn't make no discrimination for electricity. Okay, वो तो बेचारा अपना काम कर रहा है. But who does the metering? The meter thing, right? So it is the meter that is different for commercial and residential. So the commercial meters are of a different capacity than the residential meters. So what happens in a commercial meter is uska reading is little faster, and they are charged also. I think so. I don't know much about that, but I assume that the commercial meter ka typology is different than the residential one. ठीक है? So that is how. So electricity एक ही होता है, bus bar एक ही होता है, but the meters are clocked differently. Okay, so one is a commercial meter and one you have the residential meter. Okay, now let's look at this. Coming from the feeder pillar, so till feeder pillar the same thing happens. Okay, for electricity, for house also, and for institution also. From the feeder pillar you have one line coming in. One line coming in. Will you have a cutout here? Guys, hello, I'm talking about now.
Yes.
No, you will not have a cutout here. Why? I'll tell you. I told you that because everyone is responsible for paying their own bill, not a single guy. If you don't pay the bill, why should I pay the penalty of not getting electricity? So I will have a separate cutout, you will have a separate cutout. So the distribution goes like this. Line aaya, I will not have the cutout. First I will do is the distribution. First I will do is the distribution. I will distribute the line Now the distributed line will go into 41 outlets. So from the bus bar, so once the line comes in, it goes to the bus bar, it goes to the separate 41 meters. 30 is the residential, 10 is the commercial, 1 is the society bill. Okay. Now it goes to the 41 meters. Now before it goes to the meter, there will be cutout there. It will be a cutout there, so that if the commercial में एक आदमी ने नहीं भरा, why the rest of the society should face the flake of that? Why should I pay the penalty? So the guy will come and he will take, okay, the shop number 6 has not paid the bill. I am going to take out the cutout, and the rest of the shops are ablaze and the building is working. I don't have to worry about that. Fine. The society has not paid the dues for 2 months, 3 months, 4 months. What will happen? Will the flat bearers and the commercial people suffer because society has not paid? No. The society ka cutout nikal jayega, tumhara nahi. So individual flats will be still alive, okay, with electricity. So that is the distributional difference in a institutional when one payer is there and a multiple payers are there. So what happens is the line comes in, it first gets distributed via bus bar, individual line goes to the meter, but before the metering happens, you have the cutout. So once the cutout is set, it enters into the meter of 41 thing, okay, where 10 will be the commercial meters and the rest will be residential meters. From there, there will be again one fuse, because this fuse is protecting the line which is coming from the meter to individual flat, flat number 101, 102. ये सबका जो circuit ऊपर आ रहा है, who is going to protect that? It is that fuse. ठीक है? So once it comes out from the fuse, it goes all the way to your house. We will take a room number 101. So it goes and enters flat number 101, which is on the first floor. Okay, niche to stilt tha. So it enters the flat 101. Will it start directly going to the various switchboards? No. तो जो डीबी हमने KRVI का डिस्ट्रीब्यूट किया जो बहुत बड़े मायने में था, because it was supplying to some 20 ACs and blah blah blah. In your house you have just one AC or two AC and some 2-3 fans, 5-6 fans, okay, and some few lights. So the load is like minimal compared to what KRVI had. Okay, so now what happens yahan pe is that once it enters your flat, it will go to the MDB, main distribution box of 101, where again you will see all these chotu black switches, which are nothing but MCBs, miniature circuit breaker. Okay? So it goes to the main distribution box. And from the main distribution box, again, it gets distributed to bedroom 1, bedroom 2. So one line will go to bedroom 1 और उसका एक MCB होगा. Now another line will go to bedroom 2 and you will have another MCB. One, it will go to the toilet 1, it will have one MCB. You go to toilet 2, it will have one MCB. You are getting my point. I am being very deliberate here because I can't show you the diagram. I wish I could do this on a board, but so then similarly you will have living room, you will have kitchen, you will have some balconies, you will have laundry if you have that. Okay, you might have a drying balcony where you have a light there, so probably wahan ke light ke liye. So it depends on how then your guy has distributed, your electrician has distributed the light within, but ideally jitne room hai utna MCBs hota hai. So now coming to the individual room, once the line comes from the MDB, it is coming to your particular bedroom where you are there with your all architectural stuff sprayed around, and you have a table where you have a lamp and you have your computers there, you have a printer there, okay, you have a TV there probably, and you have lights and fans, the usual thing that goes around. So now you will decide again whether you want to have one switchboard or a two switchboard. वो तो फिर individual वो है. So that's, but this is how the distribution happens for an institution and for a mixed use. Now tell me, is this clear or should I repeat everything again? I don't mind repeating.
One doubt.
Yes,
From the fuse, it goes to the main distribution box of the entire house, and then
yes.
from there, it goes to the MCBs for each room, right?
No, 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 no. MCB is in that MDB. See, what
Acha,
did I
so
tell you? The golden rule is before I begin the circuit, I will install a fuse there. You're
okay,
getting it?
yeah, yeah.
It is like this. Acha, did you guys did I teach you high rise water supply in second year? I don't think so. No. Did I teach you second year mein high rise water supply where we are talking about break pressure tanks and PRPs and all the nine?
No, no.
Right? This break and we didn't get time enough, okay, which you will be doing it now. So it's a third year portion actually of how you do the water supply for a pretty high rise buildings, okay, like really high rise, say Burj Khalifa. How would you do a water supply for that? So it's obviously different from what you do. It's similarly, so if I have to handle the pressure, okay, so obviously pressure will come from छोटे से बड़ा होता जा रहा है, बड़े से बड़ा होते जा रहा है, तो where are my protection point, where it increases to a point, right? So that is where I insert my first protection device. Then again it grows, suppose, and I will have my second protection device, right? Similarly, so my first circuit is say a bedroom where you have your computer plug point. You have a lamp ka plug point because you like to work in a yellow light, and then you have probably few lights and AC ka plug point. So generally we keep AC plug point different near the AC. Why? Because line chota ho jata hai. I save on lines. I save on the wires. Okay, because those are 15 ampere. So I will generally have it nearby. Now from there, the bulk of the line is taken to the MDB. So the circuit basically ends at MDB. So which is the start point? Problem कहाँ पे होगा? ये सारा जगह का electrical load will gather and the first jolt point will be your MDB. So that will trip. So you know, okay, bedroom 1 is in a problem. उसका circuits check करो. ठीक है? Suppose that goes beyond and the whole house is in a problem. There is a massive leakage. Your house is on a say on a terrace wala flat hai. ऊपर से भी पानी है, अंदर से भी पानी है, and the walls are leaking. It's an old house, blah blah blah, whatever. And you have massive issues with electricity, and you have this tripping thing happening on and off again, and you know it is a problem. One fine day, it happens that the whole house goes blank. This happens in the old houses, huh? So don't take this as a example. This is happening in the old houses which are going for redevelopment or needs to go for redevelopment. So suppose ऐसा कुछ हुआ. The second protection point is the fuse near the meter. So the whole line का जो आपका नीचे जाता है, the second control point is your meter. And then once the meter clocks out, then the cutout is there, wo hai. So that is the strongest of the lot because that is taking care of the entire load and plus. So that is how you have multiple protection point for circuits in your entire circuit, right from the cutout till your bedroom switches. Are we clear? Are we clear?
Yeah, yeah.
Okay. Anyone has any issues? I see only Mohit asking me questions. I have
Meenal,
yes.
yeah, what decides the number of distribution box or this like for example we in water we have that like for one person you need 135 liters, so you can calculate the volume of the tank. So what decides the number of distribution boxes and how the appliances are connected to it?
Okay, a good point. See, as an architect, okay, I am more interested in deciding the modular switch boxes. I do not decide the main MDB. That is not in my purview. Okay, but it's very simple. Switchboards, just as a switchboard has a certain load on it, similarly, a certain MDBs are also available in the market or are created or customized to take certain loads. Okay, So as such, unlike water, because water is physical, it has load, it has actual physical load that I calculate in tonnage. Okay, there is no such load on electricity. It all happens in a small panel of tumhara 1 meter, so it's like I can have a whole meter room inside that. But I would say a small panel of about 30 centimeter or maybe even lesser than that. Okay, और मेरा पूरा panel उसमें आ जाता है. So I am really not worried about. So actually, the calculations for MDB is done by the electrical engineer, not by the architects, as architects do for water. And why we do for the water is because I am the person who is going to decide the number of work out the load for the structural engineer, and I have to give that to that. Not so in the electrical consumption. First point. Second point is pani you use for certain things. Okay, beyond that you don't use water. But electricity, you have uninterrupted and I would say multiple use. Okay, so a classic example. So in the old time, there was no need of so much of electricity. So they would have one or two plug points. Why not so happening today? Today, you see every switchboard will have a plug point because you have multiple chargers, you have multiple gadgets, you have a lot of things that is happening. तो पहले के ज़माने में when there were no such plug points, you know that gadget which has multiple plug points, एक लगाते हैं तो उसमें 3 plug लगा सकते हैं. Do you know that? Of course. What is our connection box which Mane gets every time so that I can have a longer length? My plug point is at the end of the door, okay, but my computer is near the board. So if I need that length of wire, I have a connection box, right? Similarly, in that connection box, there are 2, 3 ones. So in the old time, when it was not imagined to have such kind of load, suddenly people started plugging in because suddenly the gadgets were more, लेकिन घर नहीं बदला है, electricity nahi badla hai. And that's where the first failure was observed in the old houses. So what suddenly started happening, tum to tabhi born bhi nahi hue the, okay, this is that bad, I mean that old. It suddenly was noticed that buildings started having these jarring jolts of not having electricity for multiple days. Okay, and that's because too many appliances were being used where none were imagined when it was planned. The building was done in 1960. Mobile to dur ki baat, AC bhi nahi the, boilers bhi nahi the. So suddenly, when these kind of appliances were being plugged in a system which is not able to take the load, it started failing. So there were two options: either you go for redevelopment or you rehouse the entire electric system. Okay, so this is how it is. So in today's day and time, so I can go and tell you this, that per house, according to the UDP guidelines, okay, that is urban design reform guidelines, you have that per person in India, in urban India, uses about, if I'm not wrong, about 3 kilowatts per hour or something like that. I am not very certain of this. I'll find out and let you know next time. But this is how the load is. And that means from that, so he will have a computer, he will have a charger, he will use this many fans, he will have an AC, and all that compasses within 1 hour, within 1 day. And that was the reason why I gave you that formula where it says that how do you calculate kilowatt per hour? So if I'm using my computer for 8 hours, okay, I will have the wattages ready because it is available in the units, and then I multiply by the number of hours. And so I know that the total unit I am using per person per day in a house is this much. I can calculate the total load approximately again. And always electricity is planned in advance because you never know. There can be a new requirement for it in today's day and time, so that is a must. So obviously it is then charged a little bit more and then you are given that facility. So yeah, it's a big calculation, okay? But on a very generic level, the safest point from an architect point of view is if you take care of, so how do you then decide the sizes is the modular this thing. I'm not going to take that today. It's already 12:30 and it's a big thing in itself and I still have to tell you what is RCB. how do you design a panel is because of the modular or the modules that are planned and that is available in the market. What is a module? How it is planned? I will tell you that once we plan a bedroom or a living room or a house. Am I clear? So please wait for this question ka answer. Any other questions? But did you get an idea what I'm trying to say? It's not so easy as water.
Yes.
Water is physically has physical thing. This is unseen, and it's so tiny. It's electron movement, and plus it's more dangerous than water is. So yeah. Any other questions? Because I would like to stop now, or you want me to go ahead and finish this? Because I think there are still another 12 more slides. I would like to take earthing and everything next time. So this is as far as the distribution is done. So the next time when we start again with electricity, we will do the earthing, we will do the protection, and we will do the calculation. Are we done? Are we okay?
Yeah, cool.
Yeah.
Okay.
Okay.
Now, before so then can I stop the recording?
Yes.
Yeah. And before I stop the recording, I would like to take your attendance also.